Hey guys, and welcome back to this quick video on vector addition. And what we want to do in this video is learn how to define vectors based on their x and their y components. So we're going to do this one kind of like in a calculus style, if you will. So in calculus, what we're prone to write, say for example, is like vector A is defined by its x and y components. It's funny, I keep using the word calculus, but this is actually the easiest way of looking at vectors. So when I look at this first vector, I want you to define it in terms of its x and y components. So vector A, by definition, would be as follows. Well, let's look at its x component. Well, it's 10, and it looks like all 10 of it is pointing in the negative direction. So my x component is negative 10, comma. So now the question is, how much of vector A points up or down? Well, none of it. So that makes it beautiful. So our definition for vector A is negative 10 and 0. Wow, that's a really clean way of doing this. So how about this? Let's define vector B now. So vector B would be equal to, what is your x value? Well, it looks like every bit of it's pointed towards the right. So we would say 20, comma, how much of it's pointed up or down? Well, none of it's pointed up or down. So it would be 20 and 0. So now I want you to do something. Come over here and let's do this. What would be the definition of vector C? Now, vector C has got one little hitch in there. This is what we think of as a vector a lot of times via textbook, because we've got an angle in there. So there's a CX component, and this one is going to have a CY component in there as well. So we've got some components to have to deal with in terms of this one. Guys, this is really easy because my CX component, any vector x component, as long as the angle, notice this, as long as you keep your angle off of this x-axis, you can just do this. In this case, c times cosine of the angle. If you want to find your y value, then all I have to do is take my vector and times it by the sine of the angle, because sine is opposite times hypotenuse, and cosine is adjacent times hypotenuse, which is exactly what we've got. So let's define vector C. So vector C would actually be equal to, well, guys, this is really quick. All we need to do is grab a calculator, and mine's just showing up really small for some reason on my screen. But let's see what we can do. 19.7 times cosine, and my angle, it says, is 30.5. So that is 16.9. So basically, how about this? Let's say 17. So it looks like my vector is 17 in the x direction. Now, how much of it is actually directed up? Well, we can do the same thing. 19.7 times, I only have to do sine times in this calculator. I don't know what I'm thinking. It's early, and I've had no coffee. 30.5, boom. And so that's 9.99. I think we can call that 10, and that's 10 that's going up. Guys, check out how beautiful this is now. So now, say, for example, if you want to add these vectors together. So let's say we want to do this. Let's say we want to add vector A plus vector B. What would be the resultant of adding vector A plus vector B? Well, all you got to do is go up here and take a look at them. We know that, I'm going to change colors. I feel like just having a good time this morning. I know that vector A is, what are my values? Vector A is negative 10 and 0. And what was the definition of vector B? Vector B was positive 20 and 0, which makes my R, my resultant vector is negative 10 plus 20. So that's 10. 0 plus 0 is 0. Guys, that means vector R, and we could draw it. what would vector R look like? Vector R, if we drew it out in its components, would be 10 units that way. And that's all it would be. But now let's say, for example, though, you want to find a magnitude of R. Guys, to find magnitude, R is always nothing but Pythagorean. All we got to do is take my x squared plus my y squared. And you should be going, Jason, this one's pretty easy. You're right, because my x is 10 square, my y is 0, which means I'm right back to 10. There was really no reason to do a Pythagorean theorem on this one just based on that. And we could find an angle, but there's no sense doing an angle on this one either because it's just a horizontal line. Well, let's do another one. Let's do this. Let's now add vector B plus vector C. So let's check this out. What would it look like to add vector B and C? Well, if you remember, vector B was like this. Vector B was 20 that way. And vector C was the one that was up at an angle like that. So what would happen if I said, all right, guys, now I want you to add vector B and vector C together? Well, vector B, let's just do it by definition. Vector B, we said, was what? Scroll back up. Vector B was 20 and 0. So let's write down that definition. 20, comma, 0. Vector C, by definition, was equal to, let's go back and look at C. It was 17 and 10. Dun, dun. So 17, comma, 10. Guys, now it's so easy. What would the resultant be? Well, all you have to do is add these up. My resultant would be 20 and 17, which would be 37, comma, 0 plus 10. So look at what we've created. When we add these together, we've now created a right triangle that actually says we're going to the right 37 and we're going up 10. So now the question is, what is the magnitude of that triangle? Guys, all we have to do is Pythagorean. R is equal to the square root of 37 square plus 10 square. Let's type that in the Casio real quick. 37 square plus 10 square, and then take a square root of our answer, 38.3. So this is 38.3. And now if I want to find my angle is always tangent -1. And all we need is our y over our x every single time. So tangent -1, my y value was 10. My x value was 37. Take that, plug it in my calculator, shift tangent, and what we got? 10 over 37, boom, 15 degrees. So that means this angle is 15 degrees. Guys, this is such a nice little streamlined way of being able to work these problems. You can give me a list of like 30 vectors. You can give me this list and say, okay, guys, vector A is equal to, it's 5 left and 5 up. Sweet. Vector B is, let's say it's 10 to the left. I may have said 5 left a second ago. Hopefully I said right. And it's 10 down. So here you've got two vectors. You've defined them. And what's cool is if you had to like get them from scratch, just remember, we multiply by cosine to get those. We multiply by sine to get those. So what is neat is this. What would R be equal to? There is literally a chicken trying to peck my feet. Man, this is country physics at its best. 10, 5 and -10 makes -5. 5 and negative 10 comma makes negative 5. So what is my resultant? Well, this means my resultant is actually what? 5 left and 5 down. And now if you want to know what R is actually equal to, all we'd have to do is 5 squared plus 5 squares. Hey, Mr. Cole, you forgot, there's X, there's Y. Mr. Cole, you forgot the negative. Guess what happens when we square a negative? Aha! So we got 25 plus 25, so we've got the square root of 50. And then if you want to find your angle for this one, let's see, it'd be tan negative 1 of my Y value, which 5 over 5. And once again, you may be going, Mr. Cole, you forgot your negatives. I didn't need those negatives. I've already got my picture over here. I know what this thing looks like. And that actually comes out to a 45-degree angle. So, boom. Guys, this is the quickest way I know of like resolving down vectors. I hope this helps. I'll try and make a better film later. But anyway, thanks for watching, guys.